Alright, so time for the next session. So we have Bernhard presenting the experience of the Mandarian people. Mandriva people. Right, again? Alright. So in any case, there is an experience shared about the usage of clang and for Linux distribution.
So first of all, unfortunately, I have bad news. The original speaker meant for this didn't show up. So instead, we're going to have a talk about chasing a cat up a tree and keeping it there, and the speaker will be Guido. Oh, but actually, the name looks familiar. And that's actually me, so he did show up after all. So, for those unfamiliar with the OpenMandriva Linux project, we are a Linux distribution that is primarily targeting desktop users. And so far we have released versions that run on x86, 64 and i586. We have experimental builds for ARMv7 and even more experimental builds for ARC64. There's some hardware availability problem there, as many people will probably know, but there should be good news on that pretty soon. So after our last release, 2014.1, we have decided to make Clang our default compiler. Before we were using GCC 4.8. Nah, I think
it's not on C-line?
I think there's really no consensus. So some people say C-line, some say Clang.
Like, my name is also I pronounce Linux or whatever.
No, I think let's update that to my name is Guido and I pronounce Clang as well. Okay, so we are using RPM as our package manager, and the way RPM works is essentially a spec file describes how a package should be built, and that is essentially a shell script with a couple of extra tags, and a couple of macros like %configure that calls regular autoconf stuff, %cmake that calls regular cmake stuff. And as part of those macros, we can configure what the default compiler is. So for those, we just default Clang. And we also replaced the symlinks CC and C++ to Clang. So anything looking for a generic compiler will find Clang, and anything that uses autoconf or cmake will use it automatically as well. And at the same time, we switched the default linker to gold, which is actually a little bit.
No.
Yeah.
I think, I should write before 2011, pure and happy or also happy is the default for the new hash.
Yeah. So there was some switching.
Did you change the C++ library as well to use STD++?
No, at the moment we are still using libstd++ from GCC. We'd really like to switch to libc++ and also possibly switch from glibc to musl, but there's the problem of binary-only applications that are linked against what everyone else is using. And while probably the FSF would be really happy to have a distribution that says, no, there's absolutely no way you can run this binary-only crap on our distribution, it's probably not what most users would expect. So that's an interesting experiment, and we might actually do it as an experiment at some point, maybe for some embedded device where it doesn't matter, but in the main distribution.
Compiler RC or not yet?
Not yet. But that is actually one that we could start using pretty
The
soon.
FreeBSD is doing this. They're using all those things, and they link STC++ and they link the GCC into RT and libc++.
We do ship the other components, we have packages, and everything is free to link to it, but by default we don't. Because even if, for example, we link everything that comes with the distribution, the libc C++, then just ship libstd C++ for the third-party stuff. there will be third-party stuff that uses system libraries, and if, for example, Qt is compiled against libc++ and some third-party application tries to use Qt and uses libstdc++, that's causing major trouble. So, why did we make this change? We didn't have any real problems with GCC. GCC was doing well. But if we look at GCC today, 4.9, even the 5.0 snapshots, we compare it to GCC from 3 years ago, GCC 4.6, and then we do the same to Clang 3.5, actually 3.6 now, to 3 years ago, which was 2.9. We can see there actually bigger differences are being made. And if this continues for just 1 more year, probably Clang will outperform GCC on pretty much everything. I think one of the main causes is that this code is much more readable and therefore more maintainable, more optimizable. So anyone who is actually working on it, keep up the pace. So we've run some comparisons, performance and binary sizes, similar, there's no notable difference. Sometimes the GCC build is a little faster, sometimes the Clang build is a little faster, same for binary size. Overall, probably GCC is still a little ahead in performance, but not by any margin that would matter. Clang's advantages are in error messages, compilation speed, and ease of use when cross-compiling. No need to install separate tool chains and everything for every target. And most of all, code readability. So some people really don't like it. We had a guy visiting our booth yesterday, seeing the banner saying they're compiling everything with Clang these days, and he pointed out we are pure evil. No, for us it's not about the license. We don't care about the license as long as it's open source. We don't do any closed source projects. We aren't under the control or influence of anyone who does. And if Clang was GPL version 3 or GPL 4, whatever might be coming out, we'd still be using it. We are in it for technical reasons, not because of any ulterior motives that anyone might imply. So you get to switch to GCC for your fork.
Actually, I've been, I haven't used anything that much because it's just been easier for me. But now I've got the pictures, so I have to have that. So we're not actually planning to throw GCC away. We keep packaging it, and we can fall back to it by specifying CC equals GCC and CXX equals G++ to configure our CMake where it makes sense. In a couple of packages, we actually still have to do it because there's some unresolved problems. In some other packages, it may make sense because GCC is really good at optimizing some stuff. But for the most part of the distribution, we're not doing it. Overall, we didn't have many problems. We ran a mass build of our around 20,000 packages, and around 800 builds failed because of compiler changes. That may sound like a big number, but it's not actually if you compare it to the update from GCC 4.6 to 4.7 or 4.7 to 4.8. The number of failing packages because of compiler changes were always around that number. And one notable thing is with Clang, only 2 of those broken packages were because of actual compiler bugs causing the compilation process to abort. While in GCC we typically run into much more internal compiler errors.
On releases.
On releases, yeah. And on Clang they're even using snapshots, so we found it quite amazing that we didn't have that many.
That's the power of good ones.
Yeah.
Have you experienced any, like, about the instability or any other issues with CMake here on music? Software with CMake
not really, but there's a couple of problems that we just worked around by saying CC equals GCC.
Yeah, of course.
There might actually be a couple of hidden bugs that cause the broken code to be generated, but it's also possible that those are caused by IP code. That's the stuff that needs to be looked into.
About that thing, I don't agree with what you said. When you have to update the GCC version, it's quite easy to fix if you really some minor warning. But in this case, you have some crazy stuff that you have to update in the C code when you are switching to clang, like GCC expansion and very hard stuff to fix into base code. So it's not good that you can fix that easy.
No, but that's
Actually,
those things are as part of the license plan. And you have the same problem with the new secret. So,
yeah, especially if you look at some older GCC switches, especially for, okay, that's a really long time ago, but that was the most radical one from 295 to 3.0. You essentially had to rewrite a lot of code that used libstdc++ because the stricter enforcements of the standards broke everything, and I think that's pretty much what we are seeing with clang as well.
Yeah, but to switch to GCC 4.8 to 4.9 is quite easy to do. For example, in Dayton, we are doing that because we reported a triplet at that level.
Yeah, and from 4.9 to 5 it's actually not that big a step, but a lot of the earlier transitions really broke stuff a lot.
if you wrote a nice rant about if you
Yeah. So actually, he remembers some time ago, probably almost 10 years ago, I wrote a rant about it, arguing that GCC is actually doing the right thing by breaking things, and I still maintain that it is right, and clang is also doing the right thing by complaining more about non-standard code, and we'll see more of that. So, some people tend to blame the compiler for anything that goes wrong, like we had one person complaining on a mailing list, the compiler is pure crap, can't even compile hello world for me, saying the compiler cannot create executables. After debugging that a little, we found that this guy had this in his stock profile, and obviously clang doesn't understand -f record GCC switches. So autoconf or CMake or whatever he was using tried to apply those C flags, and then the compiler said, what's that? And configure said, didn't find any working C compiler. And people blame that on clang.
That's an autoconf problem.
Yeah.
The error message should be there.
Right. So, another argument for fixing build systems. And also for not putting compiler-specific flags into generic variables.
and also to get rid of all.
Right.
Yeah, that would be good.
So some of the real problems we faced was code insisting on the availability of some GCC extensions. Most importantly, nested functions that are being used quite heavily in elf-utils, and a couple of them are used in RPM. There were some other examples, but they're usually quite easy to fix by just moving those nested functions outside of the parent function and passing a couple more parameters.
Do you think this is worth one more? I give you one message.
Yeah.
Do you submit this to the RPM package maintainer and
Yes. Most of the time the patches to fix it actually get accepted, but sometimes
No longer. That's not.
sometimes some maintainers can be a bit of a pain to work with. For example, the elf-utils guy is really proud of the nested functions and how they optimize away 1 byte of memory usage or so.
like the crypto guys, fond of delays and
Yeah.
nothing's convincing otherwise.
Yeah, variable length arrays constructs primarily in the kernel. Also, we've seen a couple of similar constructs in C++ with people creating dynamic length arrays of non-POD types and expecting everything to work. but that stuff is also quite easy to patch. Just replace it with auto PTR or CLOC or whatever. And then some libcs, glibc, UClibc, I think Marcel as well assumes that built-in VAR pack exists. That GCC built-in VAR pack can be used to determine the number of arguments and some pointers inside variable argument passing.
That was last week, wasn't it?
Yeah. So, other than that, we found a lot of real bugs in code that GCC just happens to ignore. Like this piece of code where there's a friend declaration that already declares the default parameter instead of leaving that to the implementation or the header implementing the function. This might not look so bad at the first glance, but the problem is in a class everything is private by default. Therefore, trying to access this A member from main, which is not part of class A, produces an access violation in clang. GCC used to take this, but recent snapshots of GCC 5 have also started to complain about it. Then, one of the worst constructs we found actually in several places, including in some Bluetooth drivers in the kernel, is something passing an array of characters and then using size of to determine how many characters are in there, which is not how it works because that array is actually passed as a pointer. So on a 32-bit system, that size of will always be 4, and on a 64-bit system, that size of will always be 8. And you end up ignoring the rest of the array. I'm not going to point out which particular module that was because there's some security implications to that as well. Another failure that actually looked like a compiler bug at the beginning was this compilation working and then linker screaming about multiple definitions of various functions. But it turns out it was code that just assumed the C98, C89 inline semantics. Therefore, stuff that was declared inline in a header and included in several files ended up being merged into the binary twice, causing those multiple definitions. And the fix is to just use std equals GNU89 to make sure that those applications get what they expect from the compiler. The thing there is clang defaults to a newer standard, C99, where inline semantics were actually defined in a more reasonable way. So one thing that remains to be debugged that is a bit of a pain is when we build XOR graphics drivers, input drivers not so much, the X server crashes on startup. For now, we worked around that by just using CC equals GCC, but it would be nice if we found time to debug this and make sure we can build the XOR drivers with clang as well. And actually, we are always looking for volunteers, so if anyone is interested, let us know. So we're applying 2 patches to clang itself, rather than just fixing all the other packages that use it. One thing we didn't like too much was clang defining GNU-C and GNU-C minor to identify itself as GCC 4.2, because clang is actually much more standards compliant than GCC 4.2. Those defines caused quite a few things to take an if-def code path that assumed the compiler is not standards compliant, and they tried to get workarounds for that. Or even to run on a slower code path because a feature of C++ 14 or so was assumed not to be there.
Which is planned code, right? Assuming
Yeah.
a C++ feature by compiler version.
Right.
I think that 4.2 is because of legal reasons, because, GCC 4.2 is the last GPL v2, and Apple uses it, so I don't know, doesn't it?
Yeah.
So assume
So it might be hard to upstream this change to make it identify itself as GCC for 9. Yeah.
Sorry, just check. On FreeBSD were built in with the actual drivers
We haven't debugged this a lot, but when we build the Xorg drivers with clang, we just get a crash on startup, there's a backtrace, and the Xorg doesn't come up. And if you just run cc equals gcc and then configure, it works. So yeah, it might actually be a difference in default flags or whatever.
One issue we did have with a lot of the XOR stuff is that Iman really likes to pass things that don't obey C tokenization rules through the preprocessor. So explicitly configuring C preprocessor that obeys the legacy traditional semantics instead of using clang for that helps.
Yeah,
Mostly that
be a problem, but
built
I
out.
think the Xorg drivers in their current versions don't use IMake anymore, so maybe there's something in the configure script that tries to emulate that behavior. Not yet, because we were planning to debug it a bit further to actually make sure it's a clang problem and not some bad code in the X server in the way things are learned or so.
Sorry. This one, there is no C and
This one, no. Also not because of that 4.2 licensing issue. I heard about that before, and I heard that it's unlikely to ever change, so we might find a bug, but at least to make sure that the patch is out there and people can grab it.
To be honest, that should not be fixed in Clang. You know, Clang exporting GNU C at all is already wrong.
Right.
Right. So and codes relying on this for C features. You know, if they're relying on this for GNU features, that's fine. But if it's relying on this for C features, then that's completely wrong. They should
Yeah.
change their code.
That's totally true. Unfortunately, there's lots of broken code like that out there, and we don't have the time to fix it all. So the workaround for now is to do this to at least match the expectations this applications have for the most part. So one problem we ran into this is glibc assumes GCC 4.9 has built in the AR pack, which Clang doesn't have. So we had to modify glibc setters to make that assumption only if GNU-C and GNU-C minor are defined to 4.9 and Clang is not defined. But so far that's the only patch we needed to get this 4.9 thing to work. No, actually there was another one in libstd.c++ that made some assumptions on compiler standards compliance based on GNU-C version. But those two places are the only things where we had to fix stuff for that. So the next thing where we ran into some trouble was that on ARMv7 the triplets are not quite standardized. Some distributions, most things that are in some way derived from Red Hat distributions use ARMv7HL Linux GNU ABI, while more Debian-derived distributions use ARMv7L Linux GNU ABI HF to point out the hard floating point API. And Clang only understands the GNU API HF variant. So we got into a little trouble there with API conflicts, because we were using the ARMv7HL Linux GNU API variant.
Oh yeah, and if you specify the API and then you say hard float, it changes internally for the API
Yeah.
HF and then produces the API HF variant.
Right.
Yeah, that's one.
Probably they fixed that by now.
So we actually fixed that in two places. One is we added a patch to Clang that recognizes the ARMv7HL, and the other is we switched to the ARMv7L Linux GNU API HF notation, because that seems to be more reasonable.
Because one last
most of the patches to make things work are accepted upstream, so people trying to transition anything else to Clang should actually face fewer problems these days. There's a couple of exceptions, like elf-utils, as mentioned before, and glibc. The maintainers also don't care about supporting anything but GCC. We think that there may be a need to create a central repository for all those patches that aren't being accepted upstream. I'm not sure, but probably the LLVM Linux repository could be used for it. So our booth is downstairs at the ground floor towards the exit to the parking area. If anyone wants to see the system actually running completely built with Clang 3.6, minus a couple of modules for the use CC equals GCC and the likes, just drop us a visit and maybe join up and contribute some code to remove the remaining CC equals GCCs.
In handwriting.
Yeah,
Right.
no machines
Or
or
punch
patches.
Or punch cards,
Yeah, that's essentially our experience while transitioning to Clang. Does anyone have any questions or any comments?
That's a quick question. How many packages does Mandriva contain? So how many packages have been built?
We have about 20,000 packages in all the repositories combined. So the
25 if we count those ones,
yeah, but a lot of those haven't actually been rebuilt.
Yeah,
So I think
I think when she switched to the area, the package count well, quite a lot.
yeah. So the actual number of packages is more like 25,000, and the number of packages that we really tested because they are supported is more like 20,000. Because other things are just older, totally non-standard things nobody really cares about.
I wonder how much of this is in Debian use. Because Sylvester is, yeah. Do you have a similar experience on Debian?
No. So I've got, so in Debian we have 22,000 source packages, and 6% of them are failing 1,200. And we are not going to fix that anytime soon because it is C extension, it is hard stuff to fix, and I don't have the same example to do. And so we are not trying to build a data system with Clang, we are trying to see. We are trying to update every package, but it's going to take a few years. And we don't go back to the system. So it is 1,200 packages which are failing currently.
That would be interesting to share results there. Maybe we already have some patches for packages.
So what we did lately is we updated Clang, and most of our fixes have been upstream in 3.5. Basically what we did is instead of failing the build or unsupported optimization, we make Clang trigger a warning instead of an error. So it's a way we have been able to remove 3 or 400 pages not being bothered.
Yeah, I think everyone who has to compile lots of third-party code would really like to see it, but compiler engineers totally hate it because it's a complicated thing to do.
GCC 5.0 is going to default to C99, and many of our issues are going to be fixed by upstream if they still want to be compiled with GCC. So that's a good news for us.
Some of the things that we have issues with are things like I've named with the speech synthesis, speech recognition engine from CMU, which relies on old buggy GCC template two-phase lookup, and so will not build with anything newer than GCC 4.4.
Right.
The last
We have a
release-
partial fix for that actually, but it still relies on that as permissive and the likes.
The last release from upstream was 3 or 4 years ago, so the likelihood that they don't reply to email, so it's basically a test project that people use it.
Yeah, I'm pretty sure.
Or apply the patch and use the form. Each time you
Oh, also they don't have any public revision process.
Yeah, I think that was an internal project started by a university and then the class graduated and therefore it was discontinued. But the answer is to create an open repository that has fixes and maybe hope to attract some external contributors.
I think some of the issues is just so unreadable that you get a compiler error and working out what they actually meant is just, I have no idea.
Yeah. So you may want to look at the patches we are applying. So, some of them are in our FOSDEM package, which is the speech synthesizer. And I'm not so sure we are shipping the speech recognizer. I think you're talking about Phoenix, right?
Can we take those?
They have a whole suite of things, I think all of them are simple.
Yeah. And I'm pretty sure I looked at the speech recognition engine once and found exactly those problems. And fixed some of it. I found that some of the fixes required are actually the same we are already applying in FOSDEM speech synthesis. But I don't remember if I ended up fixing the rest of it or if I decided it's just not worth the trouble for now. But some of the fixes should be in the festival package, so if you want to drop by the booth and take a look.
Did you come across any issues with inline assembly in some of these packages?
Yeah, there were a few, mostly in the ARM world, where people were still using pre-unified syntax. A lot of those are fixed now, and for some others, we just use -no integrated AS and get the regular assembler from the utils.
CLM doesn't accept the email assembly that
Not all of it. On x86, I think it's actually not that much of an issue, but on ARM, there's a couple of syntax differences.
So the Chromium guys, they did the same thing. They started building like 20 different pre-UL instances that were in libraries and third-party code, etc. And it's going to take ages. Look, do it. Do it once. You don't have to do it twice. Just do it once and see how all of them accept it, like in the same day. So, I know it's time-consuming, but it's the kind of thing you fix once, and the guy actually has a better code. So,
Yeah, of course.
and they like it. They accept these kind of things.
Yeah, except sometimes you run into people who say, but we have to build this using the Microsoft compiler for Windows CE from 1985.
Well, most of the time the guy says, oh no, I cut and paste this from a website. I didn't know better, and thanks for telling me what's a better thing to do. So, most of the time it's just because they really don't know what they're doing. So, that's probably true for most of humanity, but
Right.
let's not tell into that.
Yeah, it's probably even bigger for politicians than for developers.
Yes.
Okay. Anything else? Sorry?
Impact on the speed of the compiling itself?
Yes, the compiling itself is actually quite a bit faster. So we cut some of the build times from 90 minutes in a large package to 60.
Yeah, that's what I've seen.
Yeah. GCC5 is actually catching up a little, but still Clang is ahead in terms of compiler performance itself.
How many 800 leftover packages and so on?
I don't know off the top of my head.
Because for us, that's the single biggest block that we're still using GCC4.
Yeah. There is a patch that for OpenMP, I'm pretty sure you're familiar with that.
And it's not going to be upstream.
Yeah. I hope we'll see it in 3.7 at least.
I hope we see it in 3.6.
Yeah, I think that's too late because it's already been branched, but
And it's already failing.
I have a lot of downloads of these patches.
Yeah, something similar question was asked about speed of operation. Also, did you observe anything that the code itself in performance?
Not much of a difference. So some stuff is around 2% faster, some stuff is around 2% slower. There's a couple of very specific things that GCC does a lot better. There's probably other things where Clang can do a lot better. So, actually, that's one I haven't looked into so far. Sure, it does actually.
Yeah.
Dash F4 program?
Oh,
No, I'm not sure it doesn't.
there you go.
It doesn't because well, projects that are adapted to use it, they could modify with the GC, but see them, no.
You mean the actual consultation level?
No, Dash F4 program, part of LTO.
Oh. Yeah, LTO is the thing. And there are different ways.
Yeah, well, I don't know. I see LTO, but the GC optimization. So, but, well, I think it's really nice for with the utility system.
Yeah, LTO is the
Yeah.
Okay. Anything else? Doesn't look like it. Alright, so we can go back to Guido's talk about chasing a chat up the tree and keeping it down. Alright, yeah.
Alright, so we have half an hour break until we get the next presentation of David about magic pointer